Today we'll do the second part on functions and real numbers. We got through 17. Yeah, I'll take one or two questions on homework, and we'll do more questions on homework tomorrow. Maybe. All right, questions on here? Yeah. 13? 11, 12, 13. Find the coordinates of P, values of trig functions. Unit circle. A couple ways you can do this one. Number, which one? 13. A couple ways you can do it. On 13, find the coordinates of P and the exact values of the trig functions. Okay. So on 13, which one, A or B? Both. Pi is 180 degrees. If I divide it by 4, it comes out to be 45, right? 9 times 45 is what? Have a calculator. 405. So that would be one lap around the unit circle, and then plus, that's 360 degrees, plus 45 more degrees, correct? So I'll find the sine of 9 pi over 4, cosine 9 pi over 4, and tangent 9 pi over 4, using the 45 degree mark in the first quadrant. What are the coordinates of that point? Yeah. So sine is the y coordinate, square root of 2 over 2. Cosine is the x coordinate, square root of 2 over 2. Tangent is x divided by y, or just 1. All right? And for the negative 5 pi over 4, since sine of negative 5 pi over 4, cosine negative 5 pi over 4, and tangent of negative 5 pi over 4. All right, using the even and the odd identity, just sine even or odd. That's odd. Cosine, even, and tangent, odd. So I'll rewrite it for 13b. I'll rewrite it as negative sine of 5 pi over 4. I'll write it as cosine of 5 pi over 4. And I'll write it as negative tangent of 5 pi over 4. Right. I find the sine first, negative square root of 2 over 2, because it is in the third quadrant. Cosine, square root of 2 over 2 with a negative also. And then tangent, that's going to be just a 1 because they're both negative. And then I run through my negative sign. So it's square root of 2 over 2, negative square root of 2 over 2, and negative 1. All right? Sure. For 13b, the cosecant, since it was odd, it would be negative cosecant of 5 pi over 4. It would be just secant of 5 pi over 4, and it would be negative cotangent of 5 pi over 4. And cosecant of 5 pi over 4 is square root of 2. Secant of 5 pi over 4, sorry, negative square root of 2, negative square root of 2. And cotangent is 1. Okay? So if I put the opposite of the negative square root of 2, I get square root of 2. If I do, and that stays the same, negative square root of 2, and this becomes negative 1. Right, because it's an odd function. I took the negative out. Okay? Fantastic. Yes? 5. 5?
Yeah.
Yeah, go around the back of the room.
5 and 7, you mean? Or, yeah, 5 and 7.
5. That's because you can read. You can't read? Let P and T be a point that corresponds to T. It says, this is the unit circle. It says that this is, let P and T be the point of the unit circle, of course. Okay. So this point right here is P of T. P of t is on the unit circle at 3/5 and 4/5. Someplace right about there. Okay? So if I take it, and Matt, I have to adjust my answer that we talked about yesterday because I was thinking about it. If I add pi to t, this part right here is t. It's the angle. P of t is the function value, all right? If I add pi to that, pi is a semicircle, isn't it? What happens when I move my point down to here? P of t plus pi. Right, it's going to be negative 3/5 and negative 4/5. What if I take t minus pi? Yeah, it's going to be the same way. I'm just going to go back this way a half a circle and it's still going to be the same. Now here comes the difference. T going up is going to be positive. T going down is going to be negative because negative goes down. So this point right here is actually going to be a positive x and a negative y. Okay? Because the angle is the same length, it's going down because of the negative. So it goes down first. And then it's asking if I use the negative angle and subtract pi from it, where will it end up? Well, it'll end up, if I subtract pi, it'll end up right up here. In that case, the x will be negative and the y will be positive. Okay? So those are the points based on how the angle moves. I think we didn't move it to the fourth quadrant yesterday. Was that you? Yeah. Yeah. So we need to move it to the fourth quadrant for this one. And this one's in the third, this one's in the third, and this one's in the second. Right. What'd you say? Negative t.
It'd be negative, so it'd be negative 3/5 and positive.
No, they're both negative, both in the third quadrant.
For which one? B, yeah, they're in the third quadrant, so they're both negative. D's in the second quadrant, so x is negative, y is positive. All right, time to move on. We got a lot to do today. Yes, we do. Brain break? I don't know about. We don't do brain breaks anymore in my class. All right, we'll see.
We did this.
Did we do? We did 18.
Yep.
Which one? C. We did.
We didn't do C though, but we did. We did?
Yeah, we did.
I must not have written.
All right, we all know what this means. Verify the identity by transforming the left into the right. I know, this is great. I should tweet this. Having fun and second hour trig. No, I didn't. I was busy. I was overwhelmed. Cotangent, oh yeah, it was last week. Cotangent of negative x, is that an even or an odd, Trevor? Even. So I'll take it and I'll write it as negative cotangent of x because it's an odd. What about cosine of negative x?
Is it because of the things you told us, the little graph?
No, it's because I gave you the even and the odd identities yesterday.
Oh, right.
Yeah, I have a question. How full should I note card be right now?
Probably 2/3 of one side of the note card should be full. About 2/3 of one side. So, what's the cosine of negative x? Is that even or odd?
I think it's even because
It is even because it's cosine. So that becomes cosine of x. What about sine? Is that even or odd? Odd. So that becomes minus sine of x. Okay? Now the question becomes, how in the world do you change this to match negative cosecant of x? One of the strategies was, if you weren't sure what to do, I said, yeah, change everything to sines and cosines. How do you change cotangent? Nope. Yeah, cosine over sine. Woohoo! So the cosine minus sine.
Do the negative outside of parentheses.
Well, sure, I just changed cotangent. I didn't change, I didn't put negative code. I just changed that. Oh, now it's some algebra. What's it begging you to do right there? Factor. There's nothing to factor. Yeah, multiply. So you have negative cosine squared over sine minus sine. Now what's it asking you to do? Yeah, you got to subtract fractions. Hello? Anybody there?
Think.
Yeah. Sine over sine. Hey, you can check. I got a negative in my answer right there.
How'd you get the sign next time?
Wait a minute, move. I want to see if he's moving his hand or if he's just sitting there. He's just sitting there. That figures. All right. Cosine squared. What is sine times sine? So you have negative cosine squared minus sine squared over sine of x.
How did you get the sign of x underneath the cosine for the cloud? Oh, just go change.
Yeah.
I didn't see
Now you're caught up.
yeah, I was well.
Any ideas? Any ideas? What is cosecant? 1 over sine. Is there any way to get this into a 1? Well, no, it doesn't.
You multiply everything by -1.
If you multiply both sides of your Pythagorean identity by -1, what does negative cosine squared minus sine squared equal?
Sine squared x plus
Close.
1.
2.
Negative 2.
Look, cosine squared of x
Sine x.
plus sine squared of x equals 1. What if you multiply this by -1, multiply this by -1, and multiply this by -1?
You get a negative.
This whole thing becomes -1, right? -1 over sine of x.
Which is actually that.
Yeah, you always keep your eye on the prize. Negative cosecant x equals negative cosecant of x.
Just got the most out of that problem.
Haha, nice. Okay. So, that was nice. Okay.
What?
Excellent.
Yeah.
Questions on that one? So there's some identities you're going to do. How many of them?
85,414.
Oh my.
Great.
Oh,
We're moving on. Ready?
27 to 38, what is that?
All right. This says, complete the statement by referring to the graph of a trigonometric function. Doesn't the word function imply it has to pass vertical line test? The unit circle does not pass the vertical line test. So, when you're looking at a function, you know that on your graph, on your calculator, you know that there are, when graphing out trig functions, there are going to be 5 critical values. I want to look at sine of x. So, delete, 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 and close it off. My window for this, the length of one cycle of sine has a length of 2 pi, just like the unit circle. I'm going to go 0 to 2 pi, 2 pi. You can just type in pi, it'll convert to a decimal. 0 to 2 pi, and the scale is every pi divided by 2. What's the maximum y value on the unit circle, if you remember? 1. What's the minimum y value on the unit circle? -1. So my y min is -1. My y max is 1. My y scale, I usually put it at half, 0.5. X max, 2 pi. 1 lap around the unit circle. And now you have to make sure you're in what mode? Radians. Okay?
What's the scale again?
The scale for what?
X scale.
Pi over 2. You can read the y scale, it's 0.5. So, I'm going to use all those scales, and in radians, I'm going to hit graph. So, there is what the sine function looks like. It looks like a sound wave.
Holy crap.
You're supposed to put in sine of x. So, You have to understand that because this question is asking something very unique. In other books, this question usually isn't even asked till calculus. This question is saying, as x is approaching pi, this means from the right, y is approaching what y value? Now, we made this pi over 2, we made this pi, we made this 3 pi over 2, we made this 2 pi. We set the minimum at 0, maximum at 2 pi, the scale at every pi over 2. Okay? We set that up in our x min, x max, and 2 pi and pi over 2. So, as x approaches pi over 2 from the right, for every x is a corresponding y, correct? So as you approach it, y is approaching what value? 0. As x is getting close to pi, y is getting close to 0. Okay? On this one, as x, on the second one, as x is approaching pi over 6, and this negative means from the left. Some kid goes, I never know what it means. Well, look, on a number line, what's on the right side of 0? Positive or negative numbers? Positive. On the left side, what's negative? So negative means from the left, positive means from the right.
So we're going the other way.
So we're going the other way, only we're approaching pi over 6 this time, which is right about here. So as x is approaching pi over 6 from the left, where is y approaching?
0.
It's actually right here. Sorry, right here. It is not approaching 0.
Approaching 1.
It is not. 1/2. What's the sign of pi over 6?
1/2. Why can't we?
On the unit circle, what's the sign of pi over 6?
1/2.
It is 1/2.
Well, heck, we just use our unit circle on that then. No.
On some you can. On most, you can't.
Like, could you give me an example where you can't? Like
28A.
I'll give you an example on the next section. Okay? You have to understand what the question's asking before you can answer all forms of the question. They're giving you bunny questions right now.
Okay, I got you.
Okay? So, there we go. That's how to read and interpret those questions. Sometimes there are shortcuts you can take. I don't know. I'll see. Yes, we can. Cotangent. Now, cotangent's a funny duck. Well, wait a minute. It says pi over 6 and pi.
From the right.
Well, let's do this. I guess we're not going to wait till the next section. We're going to do it here and now. So, how do I type in cotangent? 1 over what? 1 over tangent? What's another way of typing it in? No, on the calculator. Cotangent equals what on your quotient identities?
Cosine.
Yeah, cosine over sine. I'm going to type it in like that. And let's see. I'm going to change my window. I always change it to -5 to 5 for tangents and cotangents, and secants and cosecants. Yeah, I still use 0.5. Okay? Graph. There it is. Cotangent. I changed my y minimum and y maximum, -5 and 5. Graph.
So as pi over 6 is the same place it was before.
Right! So if I look at pi over 6, in the first one, that is right here. What is the cosine or cotangent of pi over 6? what's the cotangent of pi over 6? It's on a unit circle, right?
Root square root of 3.
Yeah, it is square root of 3. Cotangent is the x-coordinate divided by the y-coordinate. Sledge it out and you get square root of 3. As you approach it from the right, y is going to approach the square root of 3, which is right about there.
Yeah, I see that from the graph.
I didn't. I used the unit circle.
So this is one where we couldn't use it.
It is!
At least
So is the
We
last
have
one.
to, then?
On this one, though, what's the... Oh, here's pi, isn't it?
Yeah.
On the unit circle, now those of you murmuring right now, zip it up. I'm tired of it. I want you to listen quietly and work it out on your own later. On some of these, I said you can take the shortcut. That's fine. Like this one, it's on the unit circle. I can go to pi over 6. I can find a coordinate. I can do a value. That's great. However, at pi, there is, on the unit circle, cotangent is undefined. Okay? So on the unit circle, if I go to cotangent, I have negative 1 over 0. Negative 1 over 0. You would write undefined if you use the unit circle. You can't write undefined on this question. On this question, you have to consult the function. So some questions you can use the unit circle. Some questions you have to use this. How do you know? You have to think and make a decision. Nothing is automatic. Nothing is rote. Nothing is ever like that. You have to think. The question is, as you're coming in from pi from the left, this way, where are the corresponding y's going? As you're coming in this way, the corresponding y's are going where? How far down?
negative
Negative infinity.
Oh, okay.
That's how you answer the questions when they're written like this. Right. If I say, what's the cotangent of pi, your answer is undefined. When the question is phrased using the word approaching, the answer is different. This is a topic in calculus that some people never get, and they never get through calculus. This is a topic that some people get, and they get through calculus. If you're one of those people right now who think you'll never get this, great. You've had a window into calculus. Maybe you shouldn't sign up. If you have a window and say, hey, I kind of see how that works going down, maybe you have a shot. It's just a small window into what calculus is like. Okay? It's a different style of thinking. Instead of at, it's approaching. The answer is not undefined because I'm not writing it this way. I'm writing it approaching. Approaching means you never get there. When you say I'm approaching a store, that doesn't mean you're at the store yet. It means you're getting closer to the store. Functions deal with at the store. These questions are known as limits. They deal with the travel on the way to the store. Okay? Kind of like the difference between Twitter and Facebook. Twitter, I'm going to the store now. Facebook, I'm at the store. Okay? You only know that from the graph. That is all. That is the only way you can answer this question is from the graph. Okay? If the question would say this, if the question said x is approaching pi from the right, if you're approaching pi from the right, where's y going? It's going to positive infinity. Okay? Some people are really good. They can use this graph for both. If I'm approaching 3 pi over 2 from the left, well, yeah, it's right here. So as I'm approaching 3 pi over 2 from the left, where's y going? 0. Again, you could have got that from the unit circle, or you could have got it from this graph. So some questions you can get from the unit circle, some answers. Some you have to get from the graph. The ones you have to get from the graph are the ones that are undefined.
Okay.
There's an asymptote involved. Yes?
For A,
Yep.
have to get it from the picture.
No, if you can get it from the graph, and it has to be an exact value. Some people type in pi over 6 and they get 1.73 and try to write that down. You got to know it's a square root of 3. Okay? All right. Now, true to my word, we will take a small brain break before we get to the cosine curve and the secants. Okay? So, on this one, I'll explain it. I already said we're going to do this one called gotcha. Okay? On this one, you're going to line up in groups of 3 or 4 in a circle. You can do 5. Let's see, we'll do the first 2 rows, these 2 rows, and these 2 rows. Okay, so we'll do 2 rows, each of them have 5 in it. So you'll line up in a circle, and then you'll follow the directions. Okay? One will involves your hands, and you have to do something simultaneously. So go ahead and stand up. You don't have to like clear the area. You can like stand over the desk to make your circles. Okay? Now, this is where people cheat a lot. It's interesting to see how personalities come out in this. So you're going to take your left hand and put it so the palm is up. And now you're going to take your right index finger and place it in the palm of the hand to your right. This is on the face of the video, and
They're like holding hands on the face of the video.
that's because they got caught. So, well, we'll still do it. At the count of 3, you're try to lift your index finger up and try to grab the person's index finger out before they lift their finger up. You're a winner if your index finger is free and you have a hold of an index finger in your other hand. And yes, I think I do remember doing this one, and I do remember who the cheaters are. 1, 2, 3. Ready? Try it again. 1, 2, 3. That's good. Congratulations. Now, change your hand, left hand to the index finger and your right hand to the palm up.
Wait, what?
Change. So now you have your left hand with the index finger and your right hand with the palm up. Now, close your eyes. Close your eyes. Close your eyes. 1, 2, 3. Ready? One last time. Ready? Close your eyes. I see some of you are still cheating at this. Nice. 1, 2, 3. All right, Big John comes through. Nice. All right, have a seat.
Don't worry about Nick.
You a cheater?
All right, ready?
He was like
My
2.
other hand.
It says, refer to the graph of y equals sine of x or y equals cosine of x to find the exact values of x in the interval from 0 to 4 pi. What's the interval have to do with you in answering this question?
One full, not rotation.
That's two full cycles of cosine. Because we said that sine was 1 full cycle to 2 pi.
All right.
Now we're going to go change it. Our y equals, we're just going to do cosine. And we are now going to change our window to go 2 full cycles from 0 to 4 pi. So that changes your minimum and your maximum. I think I'll keep my scale at pi over 2. It's a good reference for trig graphs. Again, it breaks it up into the quadrants for you. And I'll change my y min, y max. I don't know. -2 to 2 is fine. -1 to 1. Because cosine's not going to go past -1 and 1. Let's go -2 to 2. Okay? Cosine. And I'll go to graph. Okay?
The big screen's slower than the little.
I know.
Lagging.
All right. So your graph is down here already. It says secant is in the blue and cosine is in the red. Interesting. And I'll go through that in just a moment right now.
There are always 2.
No, I'm getting ready to explain why they did that. So if you have a cosine graph, and it's, pretty nice and pretty large, secant we have a reciprocal identity for. We know that secant of x equals 1 over cosine of x. I've mentioned the 5 critical values before. They are at 0 because cosine is 1. They're at pi over 2 because cosine is 0. They're at pi because cosine is -1. And they are at 3 pi over 2 because cosine 0, and at 2 pi because cosine's 1. Those are the 5 critical values for cosine. 2 pi. It's back to 1. Now, since we have 2 cycles, we have 10 critical values for cosine. So, Ms. Jones, what is the reciprocal? If I want to graph secant, y equals secant. If I want to graph secant, what's the reciprocal of 1? What is 1 over 1? That's the reciprocal. Very good. What's the reciprocal of 0? What is 1 over 0? Undefined, and graphically speaking, that means it is a asymptote.
So just wherever 0, there's none.
Wherever there's going to be 0, there's going to be an asymptote for the secant graph. Whenever there's a 1, there's going to be a 1 for the secant graph. And where there's a negative 1, there's going to be a negative 1 for the secant graph. See? Negative 1, 1, 1, negative 1. Because the reciprocals of those values are all 1 and negative 1. Now here comes the whoop, filling it in. You got your basic asymptotes, you got your basic dots. Now we whoop, fill it in. Ready? What's the reciprocal of, half? What's the reciprocal of 1/2? 2. The reciprocal of a fourth? 4. So as cosine goes down, which way would the reciprocals of secant go? Up, and they would get close to the asymptote. Does the reciprocal of a negative number ever turn positive? No, it doesn't. That means this graph would go like this.
Plus, secant can't cross the x-axis.
Very good. Secant can't cross the x-axis because it's never going to equal 0. So you have this, whoop, there it is graph for secant. Yep. And you fill it in. Now, do I need to have all that to answer question number 1? Absolutely not. But they went ahead and tagged both these graphs, so you better know where they come from so you know how to read them. They said the secant was in red and the cosine was in blue, but I don't think you understand how it worked. So in this case, for what x values is cosine going to equal negative 1? Where is, I'll use a smiley face. Where's cosine negative 1? Right there and right there. What x values they correspond to? I'm so good. That's why I'm like the best ever. What x value is this going to be? What is it? Pi. Well, remember our scale was pi over 2. Here's 1 pi over 2. Here's 2 pi over 2. That's pi. And this one right here.
It's pi over 3 pi.
That's just 3 pi.
Huh?
Wait, 4 pi over.
That's just 3 pi. But
I'm talking about this one. Yeah, the other smiley face.
3 pi.
I think it's got to be 3 pi, doesn't it? Because I added how much to my picture? I normally went from 0 to 2 pi, right?
Right.
How much did I add to my picture?
2 pi.
2 pi. So these are 2 pi apart. Every maximum, every minimum is 2 pi apart on the cosine graph, unless you start tweaking numbers. We'll do that later.
That sounds like fun.
It is. Oh, man. 5th hour, they're like beating their head against the wall. This is so much fun. They're complaining. Tangent!
Odd way to say graphic fun.
Yeah.
Worries.
What does this have to do with anything with tangent?
That's
Point.
That's the window you're looking at. That's where your answers are coming from. Your answers have to come from negative pi over 2 to 3 pi over 2.
Yeah, I don't even know what I was saying.
You answered the question for 44 as it's clearly stated on the
But
slide.
I mean, like, and it's just the graph of pi and the 3 pi thing?
If you take your calculator and put in the cosine of pi, you get negative 1. If you take your calculator and put in the cosine of 3 pi, you get negative 1. There are 2 answers, pi and 3 pi. On tangent, you have no idea how many answers are going to be. So this tells you to graph it out from negative pi over 2 to 3 pi over 2. Window, negative pi over 2,
My batteries are low.
Oh.
and 3 pi over 2. Wait a minute.
Oh,
Negative pi over 2 to 3 pi over 2. Here we go. Negative pi divided by 2. Second, pi divided by 2. And 3 pi divided by 2. 3 second pi divided by 2. I think I'll keep my scale at pi over 2. It's a good reference point. For tangents and cotangents, I like to go from negative 5 to 5, just because it's personal preference.
wait, what?
Do you want to keep the y scale 0.5?
Yeah, I kept the y scale at 0.5. You can change it if you like. Yeah, it said in the problem to go from negative pi over 2 to 3 pi over 2. Okay? And I'm typing in tangent of x.
Yeah, I am.
Tangent, well then fix it. I think you guys can do that. Tangent of x.
We got the same.
Yeah, I don't know.
Okay? Graph. So, on this graph, I see 2 cycles of tangent.
I think like 1.5, I thought, or 2.5.
Wait, what?
Oh well.
Here we go. So, square root of 3 is going to be, let's see, if this is a half and this is 1, there's 1.5. There. That's about square root of 3. What angle do you think that is in the unit circle? 45? No. 60. Or pi over 3. The tangent of pi over 3 is square root of 3, isn't it? So now here comes, it behooves you to ask, if this is in the first quadrant, this is in the second quadrant, this is in the third quadrant, isn't it? If I go pi over 2, pi, 3 pi over 2. What angle do you think this is in the third quadrant, in which the tangent will equal square root of 3? So if x equals pi over 3, what's the other angle that makes that true? 240, which would be what? 4 pi over 3. They both have a 3 in the denominator. You got to learn how to read your quadrants off your functions. These are called functions because they pass the vertical line test. Could you use your unit circle? This question would be kind of tough to use your unit circle because you have to know you're going down and all the way around that way. So it's hard. You can use your unit circle as a reference point for the quadrant number 1, but you have to know it's in 1 and 3. That's why I like pi over 2 as my scale. It clearly shows me where the quadrants are. 1, 2, and 3. Okay?
No need for 4.
Well, the question is to go to the 4th.
Okay, but when it goes, okay.
Right. I have to go how the question's set up with the domain. All right? Fantastic.
So
Thank you. What?
that's it. I think that-
We answer the question to find the values of x. That's what this statement is right here. X equals pi over 3 and 4 pi over 3. Okay? If you want, you can always check it out and put those in your calculator and see what equals 1.73. That's the square root of 3. Okay? 5 minutes, thank you. And we are, let's see. Yes!
No.
No. I'm going to ask you a question. Use a graph to sketch the graph of the function without plotting points. So, I'm going to ask my administrative assistant, Miss Suits. You ready? I called on you because I think I'm going to play this video 7th hour. If that's what sine looks like, what do you think? 1, negative 1. What do you think is going to happen when I subtract 1 from it? Which way is the graph going to move? How far? Oh, it goes back to this. Remember? Inside the equation, f of x, oh, sorry, a f b x minus d plus c. Right. So it's going to move it down 1. Fantastic. So my graph would look like this. Boop. Went down 1.
Holy cow.
It even brought that 1 with it.
I know. Now that 1 turns into a 0, doesn't it? That 1 turns into a 0, and that -1 is -1, and now it goes down to -2. There's how you sketch the graph without plotting all the points.
That was fun and quick.
It was. It's always fun.
I have to kick my head against my desk.
Okay? So you can take that graph, and obviously if you shift it down, I mean, it's going to take the 1 with it. All right? So there you go. You can make graphs. Cosine. Remember, 1 cycle of cosine starts up high and does this. Sine, 1 cycle, starts like that.
Is that the thing that the people always do?
Yeah, that was the thing. People are always making that. Yeah, they're making extra credit signs.
I was in that.
Yeah.
But I wasn't in the class, so I could answer.
Exactly. So they were making those.
And the one last year. too.
Okay? Football players used to do it all the time. We'll do that one later.
So tangents,
So we'll get through 59. Okay?
tangents, like,
But how many problems are there? 50.
It goes 55 to 62.
yeah,
Yeah.
that's when you get this.
Okay, so we'll do 59. We'll do 61. Okay?
There you go, got the most out of it.
There we go.
Fantastic. Man, it feels kind of weird to make videos again.
Don't forget to make them all nice and 10.